Thank you, guys. Now that we discussed how to manage complex applications with charm operators and integration with infrastructure as code technologies, let's speak about a specific use case we have with IBM. On IBM Z architecture mainframe computers, you can deploy Kubernetes clusters. See with Lorenzo how seamless and consistent operators can be used on IBM mainframes with canonical Ubuntu Microk8s and Juju. Enjoy!
Thank you, Cedric. I am Microk8s, field software engineer in the Alliances team in Canonical. Today, I'm going to talk to you about software operators on Big Iron, which means Juju, Charmed Kubernetes operator, and Microk8s for IBM mainframes, IBM LinuxONE and zSystem machines. First of all, Juju. What is Juju? Juju is a model-driven operator lifecycle manager. It greatly improves the experience of running the Kubernetes operators, especially in such projects where you have to integrate many operators published by from different publishers. Juju also provides Kubernetes operators. The Juju project, this is an open source tool which comes with Ubuntu, the Ubuntu operating system. The Juju tool, the design has started many years ago, and now it has integrated the Kubernetes operators patterns as well. It also, of course, a universal operator lifecycle manager that extends the operator pattern to traditional applications which don't run on Kubernetes. Applications, of course, running on Ubuntu, on bare metals, virtual machines, cloud instances, so any public cloud or even on-premise clouds, enabling you to have a very good experience with operations in any multi-cloud or hybrid cloud environment. Juju allows you to embrace the operator pattern on both containers and legacy state, meaning that you can create a Juju charm, a charmed operator, and most of the code can be used to create a Kubernetes operator, a charmed Kubernetes operator, but also to create a legacy charmed operator. Meaning that, for example, for an application such as Redis, and today I'm going to demo you how Redis can be onboarded using a proper operator, charmed operator, Juju charmed operator on top of a Kubernetes substrate. For a Redis application or even any other open source applications, you can create a Juju operator in order to get such application easily installed, deployed, and managed on Ubuntu machines, bare metals or virtual machines on any cloud. But you can also reuse most of the code to create a charmed Kubernetes operator for such application. And this is very important in terms of course, efficiency and efforts on your side. Kubernetes works with Juju. Kubernetes is one of the substrates supported by Juju. As I said, Juju is an older project. We started it many years ago in order to provide a way to automate the deployment and also the lifecycle management of applications running on top of Ubuntu. Today, so there is then a number of substrates or also clouds or also provisioning systems which can work with Juju. Kubernetes nowadays is one of the substrates supported by Juju. It's just a matter of having a Kubernetes cluster, register the cluster with Juju, creating the Juju controller, which is one of the Juju system components, register, if this is needed, storage resources, add a model, and then deploy the workloads using the proper Juju charmed operator. So it's very easy. On the other side, the lacking part now is, okay, Kubernetes. I'm talking about Ubuntu on IBM machines, and IBM LinuxONE or zSystems. Which Kubernetes substrate can I install on top of such Ubuntu instances, such Ubuntu installations and machine? You know that Kubernetes is typically complex to be set up, complex to be operated. It's very complex to migrate to Kubernetes from other environments and other ways to run applications. There are also economics and vendor lock-ins, skills gap, resource consumption, tool overhead, because you know that there are many tools which provide with a way to work with Kubernetes, but this is a little bit overwhelming. And also it's a matter of security, because especially for a production-grade environment where we want to run containerized applications, security is a really important topic which has to be addressed. So one of the solutions Canonical offers is Microk8s. Microk8s is a zero operations, lightweight, pure upstream Kubernetes for single node or high-available multi-node clusters, meaning that you can, through Microk8s, you can install in a very easy way a standalone installation of Kubernetes, meaning one machine only, and at the same time, if you need for more computing power tomorrow, if you need for HA for the control plane, you can easily scale out such installation, such case deployment, adding additional machines, additional nodes, and in a very easy way, creating a cluster. Microk8s is not micro because it's a matter of poor features. It's micro because it's small. Has been designed to be small, to be packaged in a very efficient way, to require minimal operations, to be installed and also managed, clustering, upgrades, and so on. As I said, it's a pure upstream CNF certified Kubernetes, meaning that any tool you are currently using to operate Kubernetes and to work with Kubernetes can be used with Microk8s as well, because the APIs are the standard ones. Again, standalone or clustered, depending on the size of your installation, the requirements in terms of computing power and generally speaking resources required by the workloads you want to run on Kubernetes. Canonical provides it for a number of architectures, which are the ones where Ubuntu runs and is supported by Canonical. So starting with AMD64, ARM, H390X, so IBM LinuxONE zSystems, and also IBM Power. It's an opinionated Kubernetes, meaning that you can very easily install a number of features which come with Microk8s. And for those architectures where GPUs are supported, so GPU acceleration, Microk8s can also provide such GPU acceleration to the workloads, to the applications running on top of it. You can imagine, for example, AI/ML workloads, which are typically run, such as Kubeflow, typically run on Kubernetes, then GPU acceleration is a great topic. The other very great topic in our enterprise, for any enterprise-grade installation of Kubernetes, is the security, of course. So Microk8s, when I said efficient packaging system, I mean that Microk8s is distributed and delivered as a snap. A snap technology is a way to install and run applications on top of Ubuntu and also on top of other Linux distributions. This has been designed by Canonical in order to run applications in a confined and segregated way. Meaning that in this case, Microk8s, again, is a full conformant Kubernetes installation running within a confined space. So that it has no access, cannot get to the data and to the rest of the system running where you installed Microk8s, but at the same time, other applications running on the same machine cannot get to the confine the space where you are running and where you install the Microk8 using the Snap technology. So containerized Kubernetes, no moving parts, which means also better security and simpler operations. And then through the Snap technology, you get an automated way and controllable way to apply updates and also security fixes, but at the same time also to roll back. So for example, if you are running workloads on a Microk8s, again, Kubernetes 1.25, and you want to test and or need to upgrade to 1.26, you can easily do that. It's just a matter of one single command for just because you are using the Snap technology. And then you get an upgraded to 1.26 Microk8s installation, but maybe there are workloads, applications, containers which cannot run because maybe they need for some kind of tuning or OCI image, new building or whatever. Then you can easily roll back. And so with another command, you can roll back to 1.25. So it's just a matter of few commands. So very minimal operations and very low operations. There are features which come with Microk8s. It's a matter of the standard plugins available with any Kubernetes. We decided, depending on what our customers and the Ubuntu user need, we decide for which are the features, the integrations available and easily enableable using Microk8s. So it's a matter of Microk8s enable, name of the feature. And there are a number of integrations which come with Microk8s already. High availability, zero operation, self-healing installation. Because, as I said, you can start small. So you can install your Microk8 within a single LPAR, just because today we are talking about LinuxONE as zSystem machines, Ubuntu machines. On a single LPAR, you can install it within a single KVM virtual machine running within an LPAR. You can start small, but you can get at the same time, if you need for clustering capabilities, you can get high availability in a very simple way, zero operation, self-healing, and minimal M performance. For Microk8, instead of ATCD, we use DQLite. It reduces the footprint, improves the long-term performance of such installation. For example, simple clustering. We have the first installation of Microk8 standalone. We can add a node, and then we can run a number of Microk8 join commands on each node you want to get to join the cluster in order to create a real cluster. Same for the zero operation HA clustering, because Microk8 in an automated way defines who is the DB leader, who are the voters, who are the nodes which can be in standby, and also spare nodes. And when something goes wrong, for example with the leader, of course, then a new voter will be promoted to leader, and a standby node will be promoted to voter, and a spare node will be promoted to standby node. This is self-healing HA clustering. Microk8 is Kubernetes. We said that Juju can work with Kubernetes. Then Juju can work with Microk8 as well, and works with it very well to provide you with a full CNF certified Kubernetes system in under 60 seconds. This is the typical time you need to install standalone installation of Microk8. How to install Microk8 on LinuxONE machines? So it's just really a matter of having Ubuntu installed somewhere, of course, an LPAR, a ZVM guest, a KVM virtual machine, or even as an LXD system container. The Ubuntu server guide, Canonical publishes, there is an installer section which helps you and drives you to get your Ubuntu, in this case 22, so the latest long-term release of Ubuntu, installed on an LPAR, ZVM guest, KVM machines, or whatever, on your LinuxONE machine. In terms of resources, Microk8 requires around 20 gigabytes of disk space and 80 gigabytes of memory. These are the recommended resources. At least one create network interface, a couple if you want to go clustered. So if you want to install Microk8s, for example, on a number of parts in order to create a cluster, then better to have a couple of network interfaces. And then, of course, internet connectivity in order to be able to download the snap package for Microk8s, but also all the OCI images you need from the registries you prefer. Microk8s can work behind a proxy. And by the way, the demo today will show you, because the demo environment runs behind a proxy. Then I had to configure Microk8s to rely on such proxy in order to get to the internet and to the repositories and also registries. Few installation steps. Everything here is documented by Canonical. If you go on the microk8s.io website, you will find all the documentation in order to get your Microk8s installation deployed on your Ubuntu LPAR, for example. It's just a matter of one single command in order to get it installed. So sudo snap install, defining the channel. This is basically which release of Microk8s of Kubernetes you want to install. Then Microk8s and classic way. Then, since we are, for example, today, as I said, the demo environment runs behind a proxy, you need to configure the proxy, and you need to put the proxy settings, the containerd environment file. I'll show you it, but it's just a matter of preparing it. Then once you get Microk8s installed, you can move or better copy such file to the proper directory, which is in the slide here, and then restart Microk8s in order to get it able to connect with the internet through the proxy. Then for the demo today, I needed for host path storage, so a simple way to have storage resources. Of course, it's not the production grade, let's say, DNS and also local registry. And of course, being Kubernetes, there is a way, so Microk8s config, there is a way to populate the standard kubectl configuration file with the cluster data, the cluster configuration, in order to have your kubectl, which is the standard way to interact with Kubernetes, able to work and connect and get to the Kubernetes installation. Okay. Demo time. So what I want to show you today is charm the Redis operator. There is I prepared the Redis server OCI image on an Ubuntu 22.4 base image, standalone Microk8s installation in an LPAR, and then a local Microk8s registry. Let me move to this is an LPAR Ubuntu. You can see this is the release of the kernel. These are more data on the machine. What I want to show you now is sorry, I want to just show you this simple script I prepared in order to explain which are the installation steps we'll see. So first thing, of course, there is the installation of Microk8s, as we commented. We said already. Then I have a containerd environment file where I put the proxy settings I need, because as I said, this environment runs behind a proxy, so I needed to get Microk8s aware of such proxy. Then I need to stop and restart Microk8s. I want to enable these features. Then I'll populate the kubeconfig file. This is not mandatory because you can also run Microk8s.kubecontrol without to have kubecontrol installed in your system, so it's transparent. Then I'll bootstrap Juju on Microk8s, creating a model, Redis, and finally deploying my application using this charmed operator, this one, which is a local one I prepared for S390X architecture, leveraging on using a container image, a CI image I prepared for Redis server using an Ubuntu 22.04 base image. At the end of the installation, what I can show you that this is the operator. And so, for example, the operator provides a way to get the initial Redis server administrator password because I need it in order to interact with Redis server, okay? And this is something fully managed by the charmed operator. The charmed operator comes and provides the whole intelligence needed to properly operate your application during its life cycle, meaning that any charmed operator is a piece of code which may be more or less complex depending on the application you want to get automated through Juju, and depending on the number of actions and you want to run on such application during the life cycle of the application. So, for example, for a legacy application, the same Redis server application you want to run on a Ubuntu machine, on a bare metal or virtual machine, maybe you can define a number of actions, a number of operations you are planning to run on the Redis servers during its lifetime. So, for example, configuration management, configuration change, upgrades, data, maybe backup and also restore of the data. Everything here can be developed and created as a piece of code, as a Juju charmed operator, and through this Juju charm you can operate the application. Okay, so it's very simple. But as I said, the power of Juju here is the more smart is the charm, more easy will be for you to operate the application on the long run during its lifetime. So it's really important. Of course, a Juju charmed operator can be very simple, just a matter of few lines. But as I said, the more, the better. Okay. So in this case, there is I prepared the Redis case operator for S390X, is Python code in the end, and I'm going to deploy it using that command. We can test it because this is a script, and so I want to run it in a scripted way. Of course, since I have to install the Microk8s snap, I need to run it as a root user. Okay, so these are the typical operations. Look at how long does it take the installation step. Okay, so for example, we got already Microk8s installed on another window. I can, so far, I don't think, check. For example, let's see, because now Microk8s is restarting because I applied the container, the environment, so the new file with the proxy settings. So I had to stop it and restart it. So as soon it restarts, we'll start to see here the standard containers. So this is a standard installation of Kubernetes in the end. As I said, it is a fully conformant upstream CNF certified Kubernetes. So nothing is different compared with any other Kubernetes, pure upstream. Takes some time, but now we are, of course, we started Calico is the standard CNI used with Microk8s. So it needs to, of course, start Calico. core DNS because I enabled it. Same for the host path provisioning. We have just to wait 2 seconds. Of course, this is related with the computing power you have on your Ubuntu machine, because it's a matter of downloading and starting the containerized applications here, so Kali, path, registry, and whatever. And then, as you can see, the next is to bootstrap Juju, meaning that we need to create such a Juju controller, and this is the bootstrap operation. The target, the substrate, the targeted substrate here is Microk8s, and as soon Microk8s is ready, so the Kubernetes substrate is ready, Juju will start to create the container, sorry, the Juju controller. You can see there is a new controller 0 in the controller micro namespace. So this is a standard way, the standard way Kubernetes works. But what is important here is we are connecting Juju with Kubernetes in order to be able to onboard Redis and also other applications, of course. But this is just a demo and a simple demo. I wanted to show you how you can use Juju, charmed operators, and Microk8s to get full Kubernetes-related automation on your Ubuntu machine running on LinuxONE or even zSystem. Okay. Okay, the controller is there. Now we populated the Microk8s registry with the OCI image, and we started the deployment of the Redis server charmed operator, pointing to the proper OCI image on the local registry. And we can check at the same time what is the status. So let me stop this and go Juju status, which is the standard way to interact with the Juju controller to check about the status of the deployment. Because now we are deploying Redis, is already active, idle, so we can check, for example, what is, for example, in the Redis. I wanted to show you, okay, but for now, let's move on because I want to web Redis here. This is the IP address. I previously installed the command line client of Redis in order to interact with the Redis server. I get there. So now I want to run. I want to use, for example, let me create a simple variable. And then, okay. So this is working. And what is important to know is through Juju, I can also reach the single pods. For example, so there is a command, Juju SSH, which can be applied to any, of course, application, workload deployed by Juju and with Juju on any substrate. When it comes to Kubernetes, I need to point to a specific container. In this case, I want to see what the Redis container, the Redis pod. So I can easily get there using Juju SSH. As you can see, this is the Redis server. let's check which operating system are we running. As I said, this is an Ubuntu 22.04. The base image I used to prepare such a Redis server OCI image. In the same way, I can also look at the charm. So, because Kubernetes operator pattern leverage on the sidecar concept. And so there is a sidecar pod container running here, connected with the Redis server pod. This is what I wanted to show you today. The Juju status, last but not least, because we said that the demo environment runs behind a proxy, and so the containerd file is a very simple file. Here you can put your proxy settings, defining which is the proxy, and of course, most important here is a no proxy setting in order to exclude all the networks, Kubernetes networks for the pods or for internal network traffic, which have not to go through the proxy, of course, in order to have a properly working Kubernetes installation. Let me go back to my screen. And these are the components of the demo. And there are some pointers, so everything related with Juju, how to use it with Microk8s or with other substrates, how also to create a charmed operator for Kubernetes or for legacy, let's say, environments. So there is the Fuel SDK documentation made available by Canonical on the Juju website. Same for Microk8s. On the Microk8s website, you can find all the informations, how to install it, how to enable features, and whatever related with Microk8, how to cluster it, for example. Generally speaking, about what Canonical offers in terms of Kubernetes solutions, you have just to get to the ubuntu.com/Kubernetes website. And then there are also pointers related with the S39X architecture and how to get Ubuntu properly installed and working on a LinuxONE zSystem machine, no matter if you are installing within an LPAR, VVM, KVM machine, or even an LSD system container. If there are any questions, I'll be around for some time. Please feel free to ask. And now back to you, Cedric. Thank you very much.